Hey, this is Mrs. Radigan with a lesson on systems of inequalities. A system of inequalities is just a set of two or more inequalities that use the same variables. So we're going to use linear systems with x's and y's. In order to solve those, we are going to graph those two inequalities, and the solution to that is just going to be the set of all the values or all the coordinate pairs that make those two inequalities true. We won't write this in interval notation, but we'll instead view it on a graph, and we'll see an overlap of shaded areas that make up the solution to the system. When we're graphing, we want to graph lines as dotted if, like this purple one, if the inequality has no equal sign, and we want to graph solid like this red one if the inequality has an equal sign. For shading, if we have the equation in slope-intercept form and we have a less than or equal to, we would want to shade below. If we had a greater than or greater than equal to, we would shade above the line. If we're not sure if we shaded in the right area, we would just test a point like 0, 0 if it lies in the shaded area and see if it works for the two inequalities. In this first inequality, we need to make sure our equations are in slope-intercept form. So we are going to move the x to the other side and then divide by 2. And we end up getting y is less than or equal to negative 1/2 x plus 2. So we'll go ahead and graph that by putting one dot on 2, going down 1, right 2, down 1, right 2, or up 1, left 2. And then we will go ahead and draw that line in to connect the dots. And then shade, we drew a solid line because we had an equal sign there, and then we want to shade below the line since we were a y is less than. In the second equation, we're already in slope-intercept form, so we're just going to start on negative 1. We're going to go down 1, right 1. Or up 1, left 1. This one is also an equal sign there, so we're going to go ahead and connect those dots with a solid line, and then we need to shade. Since this is a greater than, we want to shade all of this area in here, and we see the place that we have the overlap area is right in the middle here. So we can go ahead and erase all that extra, or you could leave it and just leave this the darker shaded area, but this would be where all the solutions to this system lie. So any coordinate pairs that are on this part of the blue line or that part of the green line or in the middle. If we wanted, we could test a point like 0, 0 and see if it satisfies our inequalities. So if we plug it in here, 0 is less than or equal to negative 1/2 times 0 plus 2. So 0 is less than or equal to 2. That's true. Over here, 0 is greater than or equal to negative 0 minus 1. 0 is greater than or equal to negative 1. That's true. So that shaded area checks out. In this next problem, again, we need to solve for y. So 3y is less than or equal to negative 6x plus 12, which makes y less than or equal to negative 2x plus 4. So we start with a dot on 4 and go down 2 over 1 or up 2 left 1. Again, we have a solid line because we have an equal sign under there. This is less than, so we would be shading in this region here. This next equation, x is greater than negative 3, is going to be a vertical line and a dotted line on negative x going through x equals -3. And then since we're talking about shading and it's greater than, we would want to shade to the right. So in this area right here. So we can see right now we have overlap in this area right here, but we have one more equation here that we need to put in slope-intercept. So we're going to move that x over and then divide by 10. Remember, when we divide by a negative, we have to flip the inequality. And -1 divided by -2 would be a positive 1/2. And 10 divided by -2 would be a -5. So we start at -5 and then we go up 1 over 2, up 1 over 2. And then we would connect those dots with a dotted line because we have no equal sign. This is a less than, so we would want to shade in this area down here. And so we can see then that the overlap is just in this area here. So the darkened spot would be the overall shaded area, and we could erase the green and the blue and the red around that, or we could just leave that the darkened area. On the third one here, we're going to go ahead and start with this inequality, which is y is greater than or equal to -4. So that's an equals. So we are going to draw a solid line across there at -4. And then we're going to go ahead and look at this y. Oh wait, we need to shade it, sorry. So since we're talking y is greater than or equal to, so greater than is above, so we're going to want to shade all this area up in here. And the next one, y is less than -1, we're going to put a dotted line across y equals -1. Since it's a less than, we want to go ahead and shade in this area down here. So far we can see the overlap is right there. And then the last one, y is greater than x, starts at 0 and has a slope of 1. It's a dotted line because there's no equal sign. And we are going to go ahead and shade above that because it's greater than. And then we can see the overlap of the blue above, the green below, and the red above would be right in this area right in there. So we'll just go ahead and color that in a little bit thicker. There we go. And darken it. In this last example, we need to write the system of inequalities that describes each, or the whole shaded figure, by writing an equation for each, or an inequality for each piece or each side of the quadrilateral. The first one we're going to start with right here is this horizontal line going through 0. So we would start with y, and we're shaded above, and the line is solid, so we want greater than or equal to 0. This next one right here is fairly easy as well. So in this one, we're right here at 1, 2, 3, 4. This is a y value of 4 all the way across here. So we're going to add solid line shaded below. Y is less than or equal to 4 to our system of equations. This next line here goes through 0, 0 and has a slope of rise 2, run 1. It is a solid line again. It's shaded below. So we're going to add y is less than or equal to 2x plus 0. And then this last line over here has a slope of 2, rise 2, run 1 also. So 2x, it is solid, so we need an equal sign. It is shaded above, so we do a greater than. And then we need to figure out the y-intercept. So there's a couple ways you could do that. You could start by putting it into slope intercept or point slope form using the point 4, 0 that's given right here that it passes through. So we know that y is greater than or equal to y1, which is 0, plus the slope, which is 2, times x minus x1, which is 4. And then we could just distribute and combine like terms, and we get 0 plus 2x minus 8 is 2x minus 8, and that gives us that equation right there. So just remember, when you're solving a system of inequalities, you're graphing those inequalities and looking for the overlap. Your shading is below for anything less than, above for anything greater than. We use dotted lines when there's no equal sign and solid lines when there are equal signs.